Hello everyone, welcome back to my Max channel. So today I will discuss on the matrix. So multiplication of two matrix C and D, whether these two matrix can be multiplied. So we check the order first is 2 row and 1 column, so 2 by 1, and for matrix D is 2 by 2. So you notice that the number of column for matrix C is not the same with number of row for matrix D. So hence multiplication of matrix CD cannot be performed. And how about DC? Let's check. So for DC, let's check the order first. The order for matrix D is 2 by 2. And the order for matrix C is 2 by 1. So the number of the column of matrix D is the same with the number of row of matrix C. So hence these two matrices can be multiplied. Multiplication can be performed for matrix D and C. Alright. Okay, so let's discuss another example. So it is given that matrix A 2 1 3 5 and matrix B 6 negative 2 negative 7 1. So we want to calculate the multiplication of matrix AB. So matrix A is 2 3 1 5. So we will copy the matrix A, followed by we will actually write the matrix B in terms of the column. Alright, row and column. So now we are going to multiply like this. Follow the row and column. So it's 2 times 6 plus 3 is at the row 1 times with the negative 2, right? So the answer is 12 minus 6, which is 6. So the other one for the row 2 is 1 times 6 plus 5 times negative 2. So that is actually how you do multiplication of the matrix by using rows and column. So then 2 times negative 7 plus 3 times 1. Alright. So if you use the table like this, obviously you can see the logic sense why we need to multiply like this. So it's 1 times negative 7 plus 5 times 1, right? It's in blue color. So you just sum up negative 7 plus 5 is negative 2. That is actually the basic concept of multiplication of two matrices. Alright, I hope you understand. Alright, so matrix A times B, we write again. So let's rewrite again the matrix in order. So will be 6, negative 11, negative 4, and negative 2. Now let's have a look of another example, which is given that matrix E 5, negative 1, 0, negative 4, 8, 7. So we want to multiply the matrix G 4, 3 with the matrix E. So let's write down matrix G first, followed by E. So 4, 3, and 5, negative 1, 0, and negative 4 is 7. So let's multiply carefully. Okay, so FG, we will take matrix F times matrix G, and for matrix G times with the matrix F, so we would write the matrix follow the order given. Alright, so now let's have a look of how to solve. We can write the matrix like this: row 4, 3, and the column. We draw the row and the column for the matrix. Okay, like this. Now we are going to draw the column. So we have 3 columns. for matrix E and 2 columns for matrix G and 1 column for matrix F. So now we multiply carefully. Is 4 times 5 plus 3 times negative 4. So the answer is 8. Let's write down the answer. Okay, so then we will take 4 times negative 1 plus 3 times 8, right? And we simplify, the answer is 20. And finally, we will write 4 times 0 plus 3 times 7, which is 21. Okay, so we will write the answer properly according to the order of the product of the matrix, which is 8, 20, 21. The order is 1 by 3. Now for B, we will take negative 2 times 4 will do negative 8. Negative 2 times 4 for the first one, and 7 times 4 will be 28. And then negative 2 times 3 followed by negative 2 times 3 is negative 6, and 7 times 3, which is 21, right? So because the product of the matrix is actually 2 by 2, so the answer for F multiplied by G is negative 8, negative 6, 28, 21. Okay, how about GF? We will have 4 times negative 2 plus 3 times 7. So the order is 1 by 1. So it's actually just one element in the matrix. Alright. Now let's discuss another example. So let's say we want to find L square. L square, it means that L times L, the two matrices multiply by each other. So we cannot square the element. Okay, we cannot square the element. We have to multiply the two matrices. So we will take the matrix L, multiply by the matrix L. So it means that negative 4, 2, 0, 1. And then another matrix is negative 4, 2, 0, 1. We will multiply. So we will get negative 4 times negative 4 plus 2 times 0, which is 16. And negative 4 times the 2 plus 2 times 1. So we will get the answer negative 6. And then for the row 2, 0 times negative 4 plus 1 times 0, we'll get 0. And finally, we'll get 0 times 2 plus 1 times 1. So we'll get the answer, which is 1. So we can write the answer as 16, negative 6, 0, 1 for L2. Okay, so now for B, we are going to multiply K with the L2. So let's copy down the K and the L square. So we are going to multiply them, follow the order of the row and column. So let's highlight using the highlighter. Is actually follow the order. We have we have to follow the order. So we have 3 times 16 plus 2 times 0, which is 48. And the same thing go to the rest. So you have to follow systematically and make sure it's in order when you multiply the two matrices. Okay, so it's actually test your carefulness. You need to be very careful. All right. Okay, so we have complete this K times L square. So the answer you can write down later to show the product of the K times L square. So always list down the step and double check the step so that you won't make careless mistake. Alright, so now the answer is 48, negative 16, negative 16, 11, and 64, negative 26. Okay, so now we're going to do L cube, which means that L squared times L. So we will use just now the L square, which is 16, negative 6 and 0, 1 times with the L. Okay, let's do it now. So we will highlight with different color so that easy for us to multiply. So it's 16 times with the negative 4 plus a negative 6 times with the 0. Okay, so let's continue with the multiplication of the matrix. Let's do it carefully, and then always highlight using different color, and make sure you follow the order, row times with the column for the corresponding element. Okay, and if you do it carefully, I'm sure you will get the answer. And always double check, okay, the steps when you do, because careless mistake tends to happen when the things is easy. Right, so the answer that you get will be the product of the two matrices. Okay, let's see another example. For this one, you're given 6x negative 5 and then 2, 3, 1, 4 is equal to 7, 1, negative y. So let's multiply the two matrices before we refer to the answer. So this is the row followed by the matrix, which is okay 6x times 2 plus negative 5 times 1 equal to 7. So if you solve the x, you will get the answer, which is 12x equal to 12. So x is equal to 1. So another one also you have to multiply carefully is actually 6x times 3 plus negative 5 times 4 is equal to 1 minus y. So we just compare and find the values of the y, just solve the value of y, then that is the answer. Okay, so it's quite easy. After you perform multiplication of the two matrices, then you solve the unknown for the matrix equation. Okay, so we have solved this. Now let's see example number 20. The table below shows the share units purchased by Kari and Mahmoud. So you can see Kari share A 5,000 units, share B is 4,000, and Mahmoud is 2,000 for share A and 6,000 for share B. So it is given that the price for one unit of share A and 1 unit of share B is different. 1 ringgit 50 cent for share A and 82 cent for share B. So we need to find the total investment, okay, for the Kari and Mahmoud. So we will multiply the matrix, okay, with the price. Okay, so let's write down convert the table into matrix, which is 5,000, 4,000, and then 2,000 and 6,000 is the number of units. Then we times with the price for the corresponding share, we get the answer. Alright, so let's see this one. We're going to solve the exercise. So question number 1, we want to determine whether the following multiplication of matrices can be performed. If yes, state the order of the product of the pairs of matrices. Let's label down the order 2 by 2, 2 by 1, 1 by 3, and 2 by 3. So for P and Q, it seems like we will get 2 by 1. So it's the same number of column and number of row for the matrix the same. So the order should be 2 by 1. Okay, so that is how you determine the order of the matrix. Okay, let's see Q and R. So Q is 2 by 1 and 1 by 3, so it's still the same. Number of column for Q is the same with the number of row of matrix R. So the order that you get will be 2 by 3 for the product of QR. So it can be multiplied. Okay, let's see R and S is 1 by 3 and 2 by 3. So it seems like we can't multiply because they are not the same. The number of the column for R is not the same with number of row of matrix S. Alright, so it cannot be performed. S and P. S is 2 by 3 and the P is 2 by 2. So it's no, the answer, it cannot be multiplied. And finally is P and S. So it seems like they are having, matrix P is having number column 2 and matrix S is number row 2. So they are the same. So the order of the matrix of PS is 2 by 3. Right? So this is the order of the matrix. Okay, so how about Q and P? For matrix Q and P, it seems that we have 2 by 1 and then 2 by 2, not the same. So it cannot be multiplied for these two matrices. So hence we don't have to state the order of the matrix. Okay, for next one, we will discuss the multiplication of TU and UW and UV and WV, and then the last question. So let's do the TU. We will take 1, 3, 4, negative 2, 2, negative 1. Okay, that's right in order. Now we're going to multiply the two matrices. 1 times 0 plus 3 times negative 3 plus 4 times 1. So we will have negative 5 for the first element, followed by 1, 3, 4 times with the negative 4, 5, and 2. So we will 1 times negative 4 plus 3 times 5 plus 4 times 2 is 19, followed by negative 2 times 0 plus 2 times negative 3 plus negative 1 times 1. So the answer is negative 7. And finally is negative 2 times negative 4 plus 2 times 5 plus negative 1 times 2. So the answer is 16. So finally the answer is negative 5, 19, negative 7, and 16. So this is the answer for matrix T times U. For U times W, so let's do it together. So we have 0, negative 4, negative 5, 1, 2. And it's going to multiply by 2, 3, 1, negative 4. So it's 0 times 2 plus negative 4 times 3, we get negative 12. Followed by negative, we have the 0 times 1 plus the 4 times negative 4. And then we have the negative 3 times 2 plus 5 times 3, which is 9. Okay, finally we have negative 3 times 1 plus 5 times negative 4, which is negative 23. Okay, so that's the order of multiplication of the two matrices. So we have 1 times 2 plus 2 times 3, which is 8. And finally we have 1 times 1 plus 2 times negative 4, right? So we have the answer, which is negative 7. So this is the product of the matrix U multiplied by W. Okay, let's see how to do another one, which is U times V. So we will take 0, negative 4, and then negative 6 and 2. So 0 times negative 6 plus negative 4 times 2, we get negative 8. And then we will have negative 3 times negative 6, follow the color, okay, plus 5 times 2, so we get 28. followed by we have 1 times negative 6 plus 2 times 2, we'll get negative 2, right? So this is the answer for the product of U, matrix U and V. Okay, for W and V, we do the same. 2, 1, 3, negative 4 is going to multiply by negative 6 and 2. So we'll have the 2 times negative 6 plus 1 times 2. So we simplify the answer. Alright, and then followed by the next one is 3 times negative 6 plus negative 4 times 2. So we will get the answer for the matrix W times V. Okay, so that is how we multiply the matrix. So now we are going to do W square and W cube, right? Okay, so I'm sure you know how to do. So you will take 2, 1, 3, negative 4 times the 2, 1, 3, negative 4, and you do it carefully. I'm sure you can get the answer. You get 7 for the first element. If you multiply carefully, negative 2, and then for the next one you will get the answer, which is, okay, always use a highlighter, negative 6. And the final one is, after we do, we have to rewrite again, follow the row and column. The last one is 19. So let's write the answer properly. Follow the row and the column, 7, negative 2 and negative 6, 19 with a rectangle bracket. And for cube, W cube, we are going to take just now the answer times with the W. Again, we will do it carefully so that we can get the answer. So we would actually multiply 7 times 2 plus negative 2 times 3, right? So we will get the answer, which is 8, followed by we'll take 7 times 1 plus negative 2 times negative 4, which is, okay, 15. Then we'll take negative 6 times 2 plus 9 times 3. So we'll get the answer, which is 45. And the final answer will be negative 6 times 1 plus 9 times negative 4, which is negative 82, right? Okay, so 19, sorry, it's 19 times negative 4, not 9. So your answer is negative 82. All right, so let's discuss question number 3. Let's multiply the matrix first. Negative 1, y, x, and 3 times with a 4, 7. So we have to copy down the matrix, negative 1x, y, 3, and then we will times with the 4, 7. So it's negative 1 times 4 plus 7x equal to 31. So hence we will solve the x, which is 7x equal to 35. And then we get x equal to 5, followed by 4y plus 21 is equal to 29. Hence, 4y is equal to 29 minus 21, which is 8. So the y is equal to 2, right? Okay, so we have solved question number 3. Let's go to number 4. We have two matrices multiply and the product of the two matrices. Now let's copy down the matrix 9R 5 negative 2 and then 4S 6 1. So now we lower the matrix. It is 9 times 4, right? 9 times 4 in green yellow color plus the R times 6 equal to 1 5. So 36 plus 6R equal to 1 5. So we can solve the r, right? So the r is negative 21 over 6 or negative 3.5. Now let's do another one. Is 5s minus 2 is equal to 8. So 5s equal to 10. Hence the s is equal to 2, right? So we have solved the unknown. Alright, so let's proceed to question number 5. We have the g, which is p1, p5 1 negative 4, and then we have the negative 6, 7, and then 3 0. So we are going to multiply these two matrices and equate to the answer given. So let's multiply the matrix carefully. So we will find the combination which has at least one unknown. So it's p times negative 6 plus 5 times 3 equal to 3. So we can solve the p, which is actually p is 2, right? After we solve the p, now we focus to another one, which is 7p plus 5 times 0 equal to 2q. Alright, so the p we found out already, we can substitute back. Right, so then we can solve the value for the q. Okay, so we have solved the value for the q. Now finally, we will look for another unknown to solve, which is 1 times 7 plus the negative 4 times 0 is equal to 3p plus r. So we have the 7 equal to 3p, p is 2, 6 plus r, 3 times 2 is 6 plus r, hence the r is 7 minus 6, which is 1. Okay, so we have solved question number 5 with all the unknown p, q, r solved. So let's proceed to the next question. Alright, for g square, we will take g times the g, and the answer was given. So we will multiply, then we will equate to the answer given. Okay, so we take p5 1 negative 4 and we multiply both of them, so it will become g square, which is given the answer. So we will find a combination which has one unknown first. So we will take p times 5 plus 5 times negative 4 equal to negative 25. Then we can solve the p, right? So p is actually equal to negative 1. So then we will do another one, which is 1 times 5 plus negative 4 times negative 4 equal to 7q. Then we will solve it. We will get the answer for the q. Right, so the q is equal to 3. Then finally, we will solve the other one. P times p, p squared, plus 5 times 1 is equal to r. Then we will solve the r because we have the p, which is negative 1. So negative 1 times negative 1 plus the 5 is equal to r. So the r is actually 6. So let's proceed to C. Hg is equal to negative 11 2.5 q p plus 3r over 2 and 5p. So we are going to multiply these two matrices and we are going to equate with the answer given. So let's do it carefully. So negative 6, okay, we will find a combination which has one unknown. So negative 6 times p plus 7 times 1 is equal to negative 11. So we can solve the p easily. Negative 6p equal to negative 18. So p is 3. So after we got the p, we can solve the other one, we can solve the q, which is negative 6 times 5 plus 7 times negative 4 is equal to 2.5 q. So negative 58 over 2.5. So we will get the answer for the q, which is negative 23 over 2.2. Okay, negative 23.2. Then finally, we will take the other pairs, which 3p plus 0 times 1 is equal to p plus 3r over 2. And we will substitute the p, which is 3 times 3 equal to p plus 3r over 2. And we will solve the r. So finally, the r is 15 divided by 3, so r is 5, right? So the answer for r is equivalent to 5. All right, so that's how you solve the unknown for the matrix involving multiplication. So for H2, we will copy down the matrix H times with the matrix H, and then we will solve it carefully. So let's copy down the matrix H, which is negative 6, 7, 3, 0 is going to times with negative 6, 3. So negative 6 times negative 6 plus 7 times 3, we get 57, followed by negative 6 times 7 plus 0 times 0, we get negative 42, followed by 3 times negative 6 plus 0 times 3. So we will get the answer, which is negative 18. And 3 times 7 plus 0 times 0, we'll get 21. So finally, we will equate to the answer given. 6p equal to negative 42. So hence the p is negative 7. And then we will solve 1.2q is equal to 18, negative 18. So the q will be negative 18 over 1.2. So the q is negative 15. And finally, we have the answer 7r over 5 is equal to 21. So 7r is 21 times 5. Hence, 105 divided by 7 is 15. So that is the answer for r. R is equal to 15. Alright. So question number 6. Let's discuss question number 6. Mr. Cole rents a booth in Educational Expo to sell 3 types of goods as shown. The goods A, goods B, and goods C for first day, for second day, and for the third day in a table form. It is given that the profit of one item sold for selling goods A and B and C are 5 ringgit, 8 ringgit, and 6 ringgit respectively. So calculate the total profit earned by Mr. Cole every day and show your calculation in the form of matrices. So let's convert the table into a matrix with the order 3 by 3 with the respective price. Now we are going to multiply the matrix, the two matrix, so that we can find the total profit earned by Mr. Cole every day. So we will get 40 times 5 plus 28 times 8 plus 36 times 6, which is 640. And for the next row, 42 times 5 plus 36 times 8 plus 30 times 6, which is 678 is a profit. Okay, then for the last one is 35 times 5 plus 25 times 8 plus 42 times 6, and the total is 627. So these are the profit earned by Mr. Cole every day. So it seems like we can use the matrix to perform the calculation for the profit earned by Mr. Cole. So the profit is 640, 678, and 627. So that's all for the discussion about the multiplication of the matrices. So I really hope that my sharing do help you to have more confidence in solving problem involving multiplication of the matrices. Till then, see you in my next video sharing. Bye bye and have a nice day.